Yeah. Sorry for that
Okay.
convenience.
Yeah. So I'm really sorry. Okay. Yeah.
All
So
good.
yeah. So I want to talk today about something a lot of teams are running into right now, like as they move from Gen AI demos into actual production systems. So the title of the talk is uh, when agents break, and I chose that intentionally because in the production, the question is never whether your agent will fail. They will fail. They will, right? So the reason, the real question is what your system does when one of them fails. Yeah, so I'm going to use LangChain as a reference point today, mostly because it is one of the most of us have touched, but nothing I am going to say is really about LangChain. The same patterns apply if you are on if you are on CrewAI, AutoGen, semantic kernel, or a custom orchestration. Yeah, so can you go to slide 2?
Yeah, Ravi.
Yeah. So let me start with a story because I think the story explains the problem better than any definition would. So picture a 5 agent system. So the planner breaks the task down, and the retrieval agent gathers context, and the analyzer interprets it, and the validator checks the output. The executor prepares the final action. So in staging, this works beautifully. Every demo goes well, and it works in staging for a very specific reason. The inputs are clean, the paths are predictable, and when something break, you can reproduce it on the first try. So then it goes to production, and here is what actually happened. So the retrieval agent returned partial context, not an error, not an exception, just less data than it should have. So the next agent trusted it completely because why wouldn't it, right? A tool call came back with partial data. So the validator looked at the output and said it was fine because the validator was checking the format, not whether the evidence was actually sufficient. And by the time the final agent produced a response, it was polished, it was confident, and it was wrong. So nobody got paged, no alert fired, the dashboard was green. So this is part I really want to land. Agentic systems do not always fail loudly. Sometimes they fail silently and still hand the user a confident answer. That is a fundamentally different failure mode than a single LLM call returning something bad. Because with a single call, you can see the input and the output. And in a chain, the damage happens in the middle where nobody is looking. And slide 3. So why does this happen? And here is what I have found. It is almost never one big obvious bug. If it were on one bug, you would find it. It is small assumptions spread across the workflow that only became dangerous when they stack up. So let me go through a few of these because I suspect you will recognize some. So ambiguous responsibilities. Two agents both sort of handle validation. So each one assumes the other did it, and neither one really does. So weak handoff contracts, an agent passes a blob of text to the next agent, and the receiving agent has no way to check whether what it got is complete or trustworthy. Shared context pollution. So one agent writes something into shared memory, and every agent after that treats it as a established fact forever. Tour failures and partial responses. So the API returned a 200 status code with half the data, technically a success, practically a problem. No confidence thresholds. So the system has no notion of I'm not sure enough about this to continue, and weak observability, which means all of the above can happen and you will not find out until a customer tells you. So notice where this live, right? So prompt, context, tool, agent, handoff, decision, and action. So the failure that actually hurt you in production are usually clustered down at the bottom of the stack, at the handoff and decision layers, and that is exactly the part most teams do not instrument. This is why I keep saying agent orchestration is an engineering problem, not a prompting problem. Yeah, next slide. Yeah, so this is the pattern most teams start with, and I want to be clear up front. There is nothing wrong with it. A user makes a request, the planner decides what needs to be what needs to happen. Retrieval collects the data, reasoning analyzes it, validation checks the output, execution prepares the response or the action. So it is clean, and you should probably start here. What I have added under each agent is that the part that usually stays implicit. What does this agent take in? What does it do? And what does it hand off? Most teams have this in their heads or in a design document, but not in the system itself. And that is the real issue. The problem is not the pattern. The problem is that a lot of teams stop right there. So they define the agents, wire them together, was the happy path complete, and call it production ready. Yeah, next slide. Yeah, let us go deeper on the single most dangerous failure mode I have seen, which is context poisoning. So context poisoning is when one agent passed bad, incomplete, stale, or unauthorized context, and every agent after it treats that context as truth. So here is a concrete example. Your retrieval agent should have written 20 records, but it returned 3 because a filter was wrong or a service was slow. It did not raise an error. It returned 3 records and a success status. Now they analyze the reasons over 3 records and produces a confident conclusion about a dataset it never actually saw. Now, if you come from a data engineering background, this should feel extremely familiar. So this is bad data in pipeline. If bad data gets in early and nobody validates it, every downstream report is suspect, and the report still renders, it still looks like a report. So that single idea is the foundation for the 3 design principle I want to walk through next. Yeah, so principle 1, agent contracts before agent collaboration. So before agent can safely work together, each one needs a defined contract.
Mhm.
And I mean a real contract, like 6 parts, which inputs accept, like what input it accepts, what output it must produce, and what evidence it has to include, what confidence level is required, and what error it is allowed to return, and critically, what is not permitted to do. So here is what that looks like in practice. A retrieval agent should not return a wall of text. It should return structured fields. The content is it retrieved the source, including system and document ID, the timestamp, so you know how fresh it is. A confidence score and a missing data flag that says I was supposed to get 20 records and I got 3. So look at what that last field does. Remember, the context is poisoning. Example from previous slide. The entire failure disappears. If the retriever is contractually required to tell you, it came back short. And the agent receiving this is now in a complete different position, and it is guessing about what it received. It can check whether the required fields are present. Yeah, next slide. Principle 2 is a circuit breakers at the agent level. If you have worked on distributed systems, you already know this pattern. If one service is unhealthy, you stop sending it you start sending it traffic rather than letting it drag the whole system down. That idea transfers to agents almost perfectly, and I think this is underused. And yeah, and the worst thing our system can do is continue confidently with bad context. A wrong answer delivered with confidence is far more expensive than a slow answer or an honest or an honest. I could not verify this. Next slide. Yeah, so principle 3 is fallback routing. So the breaker tells you when to stop. Fallback routing tells you where to go instead. And this is what keeps the system genuinely useful when the ideal path is unavailable, which in production is more often than any of us would like. Because in production, tools fail, APIs timeout, data arrives late, models return, right? Model return the JSON that does not parse. So user asks things nobody anticipated. So if your only path is the happy path, your system is fragile by construction. Yeah, so I think with this, I would like to hand it over to my co-presenter Krishna, who will walk you through the next sections.
Yeah, thanks, Ravi. The already Ravi high level, he kind of like explained like in the agentic architecture, right? Like agent to agent, it will talk with the contrast and for the mechanism. So in the Microsoft as well, right? While we implementing this multi-agent architecture, we always see all the agents. I mean, like the happy part is like if you see the flow diagram, right, it looks always neat and clean. That uh, uh, the flow is like always, if you see the flow path, we'll feel that like everything is going in the happy direction. But in the real time, while we are building the multi agent in the Microsoft with the lot of terabytes of data, right, whatever the I mean, like in the agentic framework, what happens is like we don't see the big failure what Ravi mentioned. We always see the silent failure. So Ravi already talked about the fallback mechanism. Fallback mechanism always works that, say like isn't one say like in the isn't one, we are having like a API call. Say like in the middle of API, some network issue, some authentication issue, something happened in between retrieving the data. What happens is like while agent 1 is talking with the agent 2, what happens is like as it doesn't give the big failure, rather it gives the silent failure, while agent 1 handovering the context to the agent 2, right, it will give the data with I mean like off cooked data. So agent 2, I mean like it is not having the intelligent mechanism to understand what sort of data we need to get it from agent 1, right. What happens is like it takes the off cooked data. Accordingly, like it will process the data in the agent 2 level, and it will give the I mean like agent 2 also give the some output, right. It is also off cooked because agent 1 gave the off cooked data. Agent 2 used the same off cooked data and it processed it, and I mean like it will give the same off cooked different output, but it is also off cooked data to the agent 3. So Ravi raised the big good point that like a fault tolerance mechanism. So if using some logs or traces or uh, event mechanism, we have to understand even in the even sorry in the like each and every agent phase, what we have to do is like while agent 1 handovering the data to agent 2, we have to do the some fault tolerance mechanism to understand whether the context whatever we got it from the agent 1 is full cooked data, I mean like fully mature data or not. If so we have to make agent 2 little intelligent enough to understand if the agent 1 provided the off cooked data, it has to tell that like rather than processing the off cooked data in the agent 2, what it has to do is like it has to consider the previous context rather than the current context, and it has to process the previous context data. So that using that fault tolerance mechanism, right, like always like will do the fallback mechanism, rather than like giving the current context, we'll get the previous context and we'll pass the respective data to the next level. So we have to provide that. And second, in the agent orchestration, in the fault tolerant agent orchestration, right, what exactly orchestration job does is like even though like it is a long chain or the CrewAI or whatever the AI we use to build the respective agent, right, the real production value comes from the orchestration line layer around it. The orchestration, exactly what it does is like it controls the workflow. The agent so what it does is like the orchestration service does know what agent does what. So what is done is the it validate, it has the validator checks whether the respective handoff is complete and safe or not. If not, it use the fallback mechanism I mean, like a fault tolerance mechanism within the orchestration service, rather than take the current context, it will take the previous context and it will proceed further. So if you see the silent failures, right, always even though it shows agent success is 98.2%, but always it is not in that case. I mean, like always we need to monitor each and agent step. Did I mean, like did agent return the valid output or not? Kind of like a mechanism or the undeterministic way we can able to like check the respective output whatever the agent is providing, it is valid or not. Kind of like a validation mechanism we need to implement in agent every agentic step. Coming to the next slide, right? So uh, already I mentioned that, like I mean, like seeing the agent to agent mechanism, the flowchart wise, simple flowchart wise, it looks like a very happiest path. But what what I would like to say is, like, a pattern is bigger than the framework, meaning than the framework. I mean, like see, uh, that's what I mean. So we can use the any sort of framework. I mean, like LangChain, CrewAI, or AutoGen, or semantic kernel, whatever. Like while building the agent, but after building the agent, right? We have to do the architecture such a way that uh, it I mean, like it should handle the it should validate the all the context what agent provides, and it has to validate the whatever the agent provided the output, and in the validation step we have to validate such a way that, like whether the output whatever agent is handovering to the agent 2 or the fallback agent, it should valid or not. Kind of like enterprise architecture we have to incorporate with the respective framework agents, whatever, like a framework agents whatever they created. So that's the reason I mean, like literally called out, like a pattern is bigger than the framework. I mean, like whatever the framework you can use, but the thing is, like we have to create a while building the agent, you have to follow the enterprise architecture such a way that, like it has to handle all the edge cases. So next slide, right? We are talking about the safer agent execution loop. So as Ravi mentioned, like we'll get the request. We have to classify intent and risk of the request before handovering to the respective agent, and we have to like a build plan, like a meaning while building the agent, right? We have to like build a agent such a way that, like whether the agents are intelligent or enough to understand the request context. Kind of like the intelligent or the undeterministic or the deterministic, we have to provide the agentic framework. And every time, as I mentioned, every time we have to validate the required context in the each and every step, and we have to execute the step one by one, and each and every agentic step we have to do the validation, and we have to like rely on the circuit break mechanism, meaning if something wrong, I mean, like we have to throw error, or we have to use the previous context, or rather than using the off-cooked data. So always we have to maintain the continue mechanism, and and we have to use the fallback mechanism. If fallback mechanism doesn't work, like we have to step the agentic the respective step or the respective action, and we have to like tell uh, I mean, like there we need the human approval as well. Say like if something, say like build this multiple multi-agent architecture. Say like in the health data. Say like there we are example we are uh, 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 what I can say, like we are like validating the skin data or the some disease data. If agent is not able, not enough to like analyze the respective image data, rather than it is giving the off cooked data, right, to the handovering to the next agent. Definitely it may leads to into the different circumstances, meaning like what I can say, like it will I mean like agent may can take the bad decision. So what we have to do is like if something happened in between the agent to a to a protocol interaction, or something happened in between the enterprise level agent interaction, right, what we have to do is we have to like give the some intelligent like a undeterministic way. I mean, like use Monte Carlo or whatever the like a predictive modeling. What we have to use, and we have to identify the confidence score. And if that's the whatever the output we gave from got it from the agent, right, it is not up to the mark. What we have to do is like we have to integrate some ERP or the CRM system where we can raise the where we can implement the triage step. We can raise the respective request, and we can hand over the respective request to the human layer, where human level thing is needed. So what I'm trying to say here is like rather agent take the off cooked decisions. We need the human approval layer, where if agent not able to like take the proper decision, human will I mean like come in the middle, and it will he will take the approval. He or she will take the approval. Accordingly, the further steps, I mean like next steps will be executed. So yeah, that's what I mentioned, like human approval is the it is needed for the high risk cases, like health related agentic frameworks, or wherever some seriousness is there. If agents are seeing the off cook data, definitely we need the some human level approval for taking the next level decisions. uh, what I want you to remember is like in the multi-agent architecture, right? Always we need the fallback mechanism during agent to agent agent to agent interaction of the handoffs. Treat every agent output as a untrusted unvalidator. So meaning like a second agent. While the second agent taking the decision, right? Always we need the validation layer, where we have to validate the output whatever the previous agent has provided. We have to validate, then only like we have to create a context, and we have to provide the respective context to the next level agent. So yeah, that's what I mentioned, like always agent contracts and circuit break mechanism, fallback routing is needed inside the architecture level. And monitoring confidence, and like we have to do the some rather than depending upon the accuracy or the previous the parameters, we have to believe the confidence score using some Monte Carlo or something, some techniques. Using that score, we have to like trust the output, and we have to hand over the respective context to the next agent. And a human approval needed if the agentic framework is like handling the sensitive data or the health related data, financial risk data, wherever the risk is needed, risk is there, we have to implement the human approval layer. And yeah, this is the thing we had, like anybody has any question, we can able to answer the questions. The final note yeah, sorry, somebody is talking, but our final note is like building the agents. I mean like in the AI era, whatever the era we are having, like it is very just like a prompt engineering, we can able to create the agent. But what is the context we are providing the agent, and how well we are like our agents are talking with each other with the proper context, with the validation layer, that should matter. So yeah, while building the agentic multi-agentic architecture, right, we have to keep these things in mind, so that like we can build the a better and enterprise level architecture layer. I mean, like